Hello, my name is Ken.
And I'm Kate.
In this class, we shall teach you how to solve a question on mensuration.
The question is adapted from a November 2006 West African Senior School Certificate Examination. But before then, let's lay out a few background points.
Now, have you ever wondered what is the volume of a Sony PlayStation? Don't tell me you don't know what a Sony PlayStation is.
Of course I do, in fact. My little brother is a fan of the game. But I can't tell you the volume without identifying the shape first. That is the only way to apply the appropriate volumetric formula or volume computation.
Yeah, you're right.
So what is the shape of a PlayStation?
A cube?
No, it's not a cube. The 6 rectangular faces of a cube are all equal, or the 3 axial lengths of a cube are the same, which is not the same as a PlayStation. An example of a cube is a sugar cube or a dice.
So what shape is a PlayStation then, since it's not a cube?
Okay, a PlayStation has the shape of a cuboid.
But how?
How? A cuboid is a solid with 6 rectangular faces, the opposite faces being equal in size. The 3 axial lengths of a cuboid are not the same.
Is that why the volume of a cuboid is length times breadth times height, as against that of a cube, which is length cubed?
Yes. Now let's take a look at another object so we understand the concept even more.
Okay, what is the shape and volume of the historic Egyptian tomb?
Wow, is that how the Egyptian tomb looks like?
Yes, in fact, it is now a symbolic representation of the Egyptians.
I see. That shape is a pyramid, but the volume varies depending on the dimensions given.
But why is it not a cone?
It is not, because a cone is a solid bounded by a plane of circular base tapering to a fixed point called the vertex, whereas a pyramid is a polyhedron with a square or rectangular base and 4 triangular faces meeting at a common vertex.
Oh, I see. No wonder the base of a pyramid is a regular square or a rectangle, such that the volume of the pyramid is 1/3 times base area times height.
Yes, if you care to know how this and several other formulas were derived, check out some mathematics textbooks available to you.
Okay, let's solve the question now.
Alright, the diagram as shown on your screen is a pyramid standing on a cuboid. The dimensions of the cuboid are 4 meters by 3 meters by 2 meters, and the slant edge of the pyramid is 5 meters. Calculate the volume of a shape.
Now, pause this program and try the question yourself before proceeding. But Kate, can I try the question?
Go ahead, I'll just tag along.
Okay, let's take a look at the shape again. The pyramid is standing on top of the cuboid. It's like having the Egyptian pyramid placed on top of the Sony PlayStation. But is that even possible?
Except your imagination.
That's right. Now, can we solve the separate volumes of both the cuboid and the pyramid and then combine them to get the volume of the shape?
That's right. And since we know that the combined volume of both PlayStation and pyramid is the required volume of the shape, it therefore follows that
the volume of the shape, which is equal to volume of cuboid plus volume of pyramid. This is equal to length times breadth times height plus 1/3 times base area times height.
Can you guess the combined volume of a shape?
How do I guess that now?
Just think, Ken. You don't have to be correct. Take a look at the given dimensions and guess a possible answer.
Okay, 50 cubic meters.
Nice guess. Now, let's start and see if your guess is close. First, we compute the volume of a PlayStation, taking the dimensions to be 4 meters by 3 meters by 2 meters. Please Note that the playstations are not this large in dimensions. They are used only to represent the cuboid in the question. So Ken, you tell me, what is 4 times 3?
43?
Oh no!
I thought you placed 3 beside 4 to make 43.
How about Ken? It's like you've forgotten your multiplication table. 4 times 3 is 12 and 12 times 2 is 24.
That means the volume of the cuboid in the question is 24.
24 what? You missed the unit.
Sorry for that, Kate. 24 cubic meters.
Good. Okay, let's move on. Now, what is the volume of a pyramid standing on top of a cuboid or the PlayStation?
It's simple. Just apply the formula. Volume of pyramid equal to 1/3 times base area A times height H.
It sounds simple, but the process is not that straightforward. You need to think critically as you solve along.
Yes. First of all, the base area can be computed simply by multiplying the dimensions of the length and breadth of the cuboid. By the way, that is how to calculate the area of a rectangle, length times breadth.
So the base area of the pyramid is 4 times 3, which gives us 12 meters square. Note that this time the unit is meters square because only 2 quantities in meters multiply, unlike the cube in volume.
Okay, from the question, we were given the slant height of the pyramid, but not the vertex height.
Now what's the difference, Ken?
Vertex height is the vertical height between the vertex of the pyramid and a point perpendicular to the horizontal plane, whereas a slant height is between the vertex and any point on the edges of the base. This difference is extremely important because students miss their steps here so often.
Are you serious? That means that the height in the formula is the vertex height and not the slant height.
Yes, that is what it means. And we were given the slant height to be 5 meters.
Wow. But that's a problem. How do we determine the vertex height then?
Good question. We need to position the pyramid in such a way that a known mathematical principle can be applied to solve the height. So think, how do we do this?
Can we deduce a triangle within the pyramid that connects the vertex height we're looking for, that is, the slant height we were given, and half of the base diagonal, where the base diagonal can be derived from the given dimensions of the cuboid below the pyramid?
That's a good idea. In fact, from what you said right now, I just realized proficiency in mathematics requires lots of thinking, not just knowing the formulas and how to apply them.
Yes, in fact, that's the way to ensure the accuracy of your workings. Okay, let's proceed. First, denote the height we're looking for as h. Then, denote the diagonal as b. What we need though is b over 2 from our triangle. Now, to estimate the value of d, we'll apply Pythagorean theorem.
What? Pythagorean theorem? What is that?
A Pythagorean theory, named after the inventor Pythagoras, states that the square of the longest side of a right-angled triangle called a hypotenuse is equal to the sum of the squares of the other 2 sides. What that means is, if the length of any 2 sides of a right-angled triangle are known, then the length of the other third side can be found. But please, note that this law only applies to right-angled triangles.
I see. If we are to apply that, we would have b to be the longest side of the right-angled triangle formed with 4 and 3 as the other 2 sides.
Yes, this therefore becomes
b squared equal to 4 squared plus 3 squared. So we solve. 4 squared is 16 plus 3 squared is 9. 16 plus 9 is 25. We now have b squared to be equal to 25. The square roots of both sides are b and 5. So b is equal to 5 meters.
Good Good. But remember, we need b over 2 to find h.
Yes! So b over 2 is 5 divided by 2, which gives us 2.5.
Alright. Note that all we've done so far is to derive the value of b over 2, which is 2.5. That, with the 5 meter slant height and the unknown value of h, now forms a new right angle triangle.
Alright. Let me take it from there.
Yeah. With our new value now.
Kate, I thought I said let me take it from there.
Yes, you did. It's becoming rather interesting. Let me finish it, please.
Alright, go ahead.
Thank you, Ken. Applying the Pythagorean theorem again, we can then have our values as 5 squared equal to h squared plus 2.5 squared. By collecting all terms, we then have h squared equal to 5 squared minus 2.5 squared.
5 squared is 25, whereas 2.5 squared is 6.25. Now, 25 minus 6.25 is 18.75. H squared is now equal to 18.75. Taking the square root of both sides, we then have our h to be equal to 4.33 meters.
Interesting. Okay, with our derived vertex height h, we'll then proceed to find the volume of a pyramid.
That's right. We know the volume of the pyramid as 1 over 3 times base area times vertex height. We'll simply impute the figures derived and calculate.
Alright, our soft base area is 12 meters square and the derived vertex height is 4.33 meters.
Hence, the volume of the pyramid is now 1 over 3 times 12 times 4.33. 3 divide 3 is 1, whereas 3 divide 12 is 4. 4 times 4.33 would give us 17.32 meter cube.
That's correct. So to finish up this calculation, we'll add the volume of the cuboid and that of a pyramid together. And that will be 24 plus 17.32 meters to give us 41.32 meters cubed. That is the final answer.
Wow! Can you see that my guess of 50 cubic meters is very close?
That is true. Nice one. Okay, dear viewer, is that what you got? I hope it is.
Now, let's quickly review how we solved this problem. First, we related the problem or shape to something we understand and relate to. That is, a PlayStation and the Egyptian pyramid. We then split the shape into the obvious two parts and calculated their respective volumes. Finally, we added these volumes together to get the volume of the shape.
Meanwhile, let's give you another problem to solve on your own. That's the way to be sure you understood the thought concepts very well.
Yeah.
Okay. The following problem is a West African Senior Secondary Certificate Examination of November 2010 exam question, which is as follows. OABCD is a right pyramid with a rectangular base ABCD. Its vertical height is OG. If length AB is equal to 6 cm, length BC is equal to 8 cm, and each slant height is 13 cm, A. Calculate correct to one decimal place the vertical height of length OG, angle between a slant edge and the base ABCD, angle between the triangle AOB and the base ABCD. B. Find the volume of the pyramid.
Now pause this program and answer the question before continuing. Meanwhile, the answers to these questions are: A. Roman numeral 1, OG equals 12 cm. A. Roman numeral 2, angle OAG equals 67.4 degrees. A. Roman numeral 3, angle OFG is equal to 71.6 degrees. And B. Volume of pyramid is equal to 192 cubic meters.
Okay, that will be all for now. Why don't you solve the questions and check if your answers are right? Thank you for watching.